Hey guys, um, welcome to solving systems of inequalities word problems. So we're going to do what we did last week, try and take it one step further and use this in real world situations. So let's go ahead and look at the first example here. It says that you can work a total of no more than 10 hours each week at your two jobs. So you've got two jobs. One is a house cleaning job that pays $5 an hour, and the other one is a sales job that pays $8 an hour. It says you need to earn at least $56 each week. So it seems like it's important, at least $56 each week to pay your bills. Write a system of inequalities that shows the various numbers of hours that you can work at each job. So first things first, we need to define kind of like what we're talking about. So I'm going to use X and Y for this example. So let's let X be the number of hours at the house cleaning. So the X is going to be how many hours a week you work at this house cleaning job. And then let's let Y be the number of hours at the, what's the other one? The sales job. The sales job. Okay. So now we need to come up with two inequalities and graph it. Coming up with the inequalities is probably going to be the hardest part. But if you take it little piece by piece and really think it through, and once you see some examples, you'll get used to how they're written. So for the first one, we want to do $5 per hour, right? Well, do we know how many hours we're working? No, but we do know that X is representing the number of hours of the house cleaning job. So we're going to write 5X. So 5 times the number of hours is going to give us how much we make at the house cleaning job. And we're going to add that to the sales job, and we said that Y is going to be the number of hours for that one. And then how much money, so this is going to give us our money, right? So we need to know how much money we need to make each week. And it says up here we need to make at least $56, right? At least $56. So this number on this side's got to be bigger. So we're going to use greater than or equal to. And don't forget about the equal to, right? Because it says at least 56, right? So 56 is good. We can go 56 and above. So I'll put 56 over here. And that's our first inequality. Second inequality is going to be the one talking about this 10 hours right here. This 10 hours a week. X is the number of hours for house cleaning, plus we're going to add the number of hours for sales job, and it's got to be no more than 10 hours. So this can't be bigger than 10. So this has to be the bigger number, so we're going to use a less than or equal to sign. So we've got our two inequalities. Now we just need to get Y on the left side, and then we can graph them. So let's take a look at this one. So 5x plus 8y is greater than or equal to 56. I'm going to subtract 8y. So I've got 5x is greater than or equal to 56 minus 8y. And then I need to divide by 5 on both sides. Divide by 5, divide by 5. Divide by 5. And, oh, do we see a mistake that I'm making? What was I solving for? I was actually solving for X and not Y. So let's fix that real quick. Sorry about that. Let's see if I can't scoop this up either. There we go. Okay. So what do we have? 5x plus 8y greater than or equal to 56. We need to get x on the other side. So we're going to subtract 5x. So we'll get 8y is greater than or equal to 56 minus 5x. Now we can divide by 8 on both sides. Divide by 8. This is looking better. So I've got y is greater than or equal to 7 minus 5/8 x. And then for this one, we can do x plus y is less than or equal to 10. I'll just subtract x. Sorry about that. Subtract x, and I get y is less than or equal to 10 minus x. Okay, so these right here, these are our inequalities, and we can graph them. So x is always going to be on your, let me move this over. X is always going to be your x-axis. So this is, let's put house cleaning down here. We can put sales job over here. And let's just graph this one first. So y-intercept, this is your y-intercept. We're gonna go up 10. So I'll have a point here. And there's like an invisible 1 right here, right? So there's an invisible 1. I can always write that out of 1. This is my rise over my run. Or another way that you could do that is y over x. Okay, so now up 10. So I'm gonna go down 1 over 1 because of this right here. Down 1 over 1. And then it's gonna go all the way down. And I have a fancy ruler this time. So I'm just going to, and then is this gonna be a dashed or solid line? Well, this is gonna be a solid line because it's got the equal to bar there. So there we go. There we go. And now we need to graph this one. So again, this is your y-intercept. This is your slope. And let's move it over so you can see it. There you go. So we're gonna go up 7. So right here. And then I'm gonna go down 5. 1, 2, 3, 4, 5, and over 1, 2, 3, 4, 5, 6, 7, 8. About right here. And then again, it's a solid line, and I can connect these. There we go. And then trick for shading, if it says less than, then you're gonna shade below the line. If it says greater than, you're gonna shade above the line. So this line right here is for this inequality. Since it's greater than, I know I'm gonna shade everything above. And then this one right here is less than. So this is the second line, so I'm gonna shade everything below. And what you end up getting is everything in this shaded area right here. And what this is telling us is that, hey, I can work 2 hours at my cleaning job. Okay, well, if I work 2 hours at my cleaning job, how many hours do I have to work at my sales job? Oh, well, if I go up, I would have to maybe say right here, 2 hours, I would have to work 7 hours at the other job, at the sales job. Or I could do 2 hours and only 6 hours, I'd still be good. Or maybe I only wanted to work 1 hour at the cleaning job, then I would have to work 7 or 8 hours or 9 hours to still keep under 10 hours, but still make $56 at least. Same over here, 6 hours of cleaning would require what, 3.5 of a sales job? So yeah. All right, I'm gonna pause it here and then I'll put the other examples in a different video.